Okay, so Bismillah Rahman Rahim. Now, today is lecture number 1 of the course Irrigation Engineering. So, in today's first part of the lecture, we will discuss about the course outline. First, we discuss the course aim to develop understanding among students towards water resources, hydraulic structures, and irrigation systems, salinity and water logging, and water management practices. So this is the course aim. We have to study about the water resources, what are the different sources of water available to us, and then we will discuss the water resources availability in the context of Pakistan. Similarly, we will discuss about the hydraulic structures. So as you can see that we have to construct different hydraulic structures for different purposes. For example, you see here a dam. So dam is a multi-purpose structure. We store the water and then we can use that water for meeting the different water demands. So why we need to construct dam? Because if we have enough water available in the river, so that we can meet all the demands by extraction of water from the river, then no need of construction of dams. So you can see that, and you have studied in hydrology also, that the river flows, they are not uniform throughout the year. So at times we have high flows and low flows at other times. So because the demands that we have to meet, the water demands in the form of domestic water supply, industrial water supply, water for agriculture. So these demands we have to meet throughout the year. So for that purpose, we need to construct the dam so that during high flows in the river, we can store the water. And during low flows, when the water is not sufficient to meet the demands, then we can supply the water from these dams and reservoirs. So we will study about the dams. Similarly, we will study about the irrigation systems. As you can see here that irrigation is the artificial application of water to crops. We have to grow crops because we need food for survival. So the crops, they require certain amount of water from time to time. So we have to supply the water. For this purpose, we develop what is known as irrigation systems. So irrigation system is basically a network that include dams, weirs, barrages, canals, which are artificial channels, and other systems that we use to supply the water. For example, you see here we are using sprinklers to sprinkle the water, and here a pipe that provides controlled supply of water directly to the plants, trees, crops. So we will study different types of irrigation systems. If we have uniform rainfall that is sufficient to meet the crop water requirements throughout the crop period, then we don't need to artificially supply the water. But as you know that rainfall, it is not uniform. So the crops, they need water in quantity that is required for growth and at the right times. So it's very difficult that we have the rain that can provide the required quantity of water at the correct times for nourishment of the crops in agriculture. For this purpose, we have to provide artificially the water to the crops. So for this, we provide a system that is known as irrigation system. Also, we will study about salinity and waterlogging. So salinity means the salinity salts that we have in the soil that are undesirable for plant growth. What can happen is that if the water table in an area, it can raise up to the earth's surface. So what will happen is that the plants, they will be underwater. So this is not beneficial. This water logging, it is actually the raising of the water table in any area that can adversely affect the land productivity. This is known as water logging. For example, you can see here in this picture that we supply water to the crops. So the crops can use the water for growth, and the rest of the water it can drain. It can either infiltrate into the soil and join the groundwater, or it can drain in the surface drainage network. But if the same plants, if they are standing in the water for longer time, which is not desirable, the same plants can die. So this phenomena, this is known as water logging. And when the water table raises near the surface, comes to the root zone, it also brings the salts from the soil and make the land surface not productive for agriculture growth. So this is known as salinity. So these are actually problems that we face. So we will study that what are the different causes of salinity and water logging and how we deal with these problems. And we study about the water management practices. So how we can better manage the water at the catchment or basin level. Actually, we can have water management practices at the farm level, where we have to see how to introduce the scheduling of the crops, the crop pattern, etc., so that we can maximize the food production. But we will be more interested in water management practices at the basin level, at the catchment level, that how we can better manage the water, make it more useful. And this can include construction of new dams, reservoirs, weirs, barrages, improving the network of canals, and the method of water supply to the crops. For example, you can see here in this picture that we just flood the area. So not all water is used by the crops for growth. So consequently, the irrigation efficiency, that is very low. And this is what is commonly practiced in Pakistan, and the reason given for that is that we have plenty of water available. But in the Western countries, where they are using less water for irrigation purposes. The reason is that they are using more efficient methods of water supply to crops. Just like you see here, that we have a sprinkler system, and just we spray the water over the crops, and in this way we can save the water. If we want to further make the water supply efficient, we can use this drip irrigation system, where we have a network of pipes, and just with the drops of water directly under the trees, plants and crops, we supply the water. That way we can save a lot of water and the irrigation efficiency is more. So all this basically includes water management practices. So after we study this irrigation engineering course, students are expected to have a good understanding towards water resources, hydraulic structures, and irrigation systems, salinity and water logging, and water management practices. The course learning outcomes: upon successful completion of this module, students will be able to define basics of irrigation and water resources engineering. So this is CLO 1 of the course, that you should be able to define the basics of irrigation. What is irrigation, Claire? What is irrigation system, different types of irrigation system, the different hydraulic structures that we need to provide, and so on. So you should be able to define the basics of irrigation and water resources engineering. The second CLO of the course is describe different methods, principles, and processes involved in irrigation. So you should be able to describe the different methods of irrigation, the other principles and processes involved. For example, we have the different types of hydraulic structures that we need to provide. We have dams. Then we have to supply the water to the crops through a network of canals. So you should be able to describe those canals, how we design them using different theories that we will study in this course, and the other small hydraulic structures that we will encounter. For example, if a canal is going to cross a small stream or drain, so how we cross them? Should there be a level crossing that the water joins and then it is again withdrawn on the other side, or we have to take the canal above the drain or stream, that is known as aqueduct, or we have to take below the drain or stream, that is known as siphon? So you should be able to describe all these. This is CLO2. You should be able to describe what is salinity and water logging, what are the different causes, how can we deal them. The third CLO is the knowledge that we get in this course should be able to apply the knowledge of irrigation engineering to solve basic and complex problems. So the knowledge that we will acquire through this course, you should be able to solve the complex problems. For example, what are the sources available, how we can develop the irrigation project. For example, you have an agricultural land. For that, we need to supply the water. We have to identify what are the sources available, and then how we supply that water to that agriculture area. what kind of irrigation system we need to provide, what type of hydraulic structures we have to construct, how we have to operate and maintain successful execution of that irrigation project. So by end of the course, these course learning outcomes should be achieved, and these course learning outcomes, they contribute towards what is known as PLOs. So you can see that these CLOs, these are linked with PLO1 and PLO2. PLO is the program learning outcome. So as you have studied so far that all the courses that you study, we have CLOs separate for each course depending upon the nature of the course, and then these CLOs are linked with the PLOs. So the CLOs scores that you will obtain in this course, that will contribute towards PLO1 and PLO2. Teaching learning activities. So the course learning outcomes will be achieved through a combination of the following teaching strategies. There will be instructor lead presentations. There will be classroom discussions in the form of question and answer. Since we have to deal with design of irrigation canals, dams, hydraulic structures, the crop water requirements, so there will be classroom examples to apply the theory to solve the problems. Then assessment will be made by quizzes and home assignments. There will be a midterm exam for this course and a final comprehensive examination. Now, briefly, these program learning outcomes, these are program outcomes are the narrower statements that describe what students are expected to know and be able to do by the time of graduation. So actually we have many PLOs, total 12. But you can see that this course, the CLOs that you will obtain, that will contribute towards the PLO1 and PLO2. That is, you get the engineering knowledge and be able to apply the knowledge to the solution of complex problems. Engineering knowledge and then problem analysis. We have other PLOs, just like here. PLO3 is design development of solutions. PLO4 investigation, then modern tool usage, engineer and society, environment and sustainability. Ethics, individual and teamwork, communication, project management, and lifelong learning. So you study different courses, and those courses, they will contribute to one or more of these PLOs. So as you already know that in the outcome-based education system, OBE system, so you are assessed through these CLOs and PLOs, and we have the relative grading. On one side, you get a grade based on your performance in the course, and then on the other side, we evaluate you for these course learning outcomes. Now the course syllabus. So the first topic is introduction to water resources. In this topic, we will study about the water availability on Earth and what are the different water resources. We have rainfall that can supply water to any area directly. Similarly, we have the surface source, which is in the form of rivers. So rivers can flow from one area to another area and carry the water. And the third source is the groundwater. So the groundwater is not directly available. We have to pump the groundwater and then we can put it to multiple uses. So in the first part of this course, we will study about introduction to water resources. Next, we will study about what is irrigation, what is irrigation engineering, what are the different methods of irrigation, irrigation water requirement and its measurements, irrigation water quality, and irrigation systems. These are the different systems through which we supply water to the agriculture area. So in this we will study what is irrigation, which is the artificial application of water to crops. So since we artificially supply the water to crops, we will study that what are the different methods of irrigation. So we have surface irrigation system or the groundwater that is used for irrigation purposes. Irrigation water requirement, how we can calculate the water needed by certain crops for their growth. We will study how to calculate that water, based on which we supply the water to the agricultural land. So this is important. First, we have to determine that we are growing a particular crop. Throughout the crop period, how much water this crop will require for growth and at what intervals. So this is what we can calculate. Since we have to supply the water for crops, we should also check the water quality. Just like you study in environmental engineering, when you supply a water to a community, you have to check the water quality. So if the water quality is not good for drinking purposes, we have to treat the water. So you have water treatment plant. Similarly, we have to check the water quality for irrigation purposes. And the different systems, after we have the water from surface sources or ground sources, once you have the water, then how the water is applied in agriculture field, this agriculture irrigation systems, clear? So we have different types that we will study in detail. We will study about the canals. Canal is artificial channel, open channel that supplies the water from the source to the agriculture fields. So we will study design of irrigation canals. So canals can be of two types, erodible, non-erodible canals. We will try to study both in detail. So how we design them. we have different theories to design the irrigation canals that include Kennedy's theory, Lacey's theory. Similarly, we will study about the canal lining because we construct the canal to carry the water. So why we need to provide the canal lining, we will study its advantages and types. So canal lining basically means that we supply the surface of the canal, the sides and the bed of the canal with impervious materials, because if canal lining is not done, the water seepage can take place and it can result in reduced supply of water. We will also study about maintenance of irrigation canals. When irrigation canals are designed and constructed, they supply water to crops. So because they carry the water, then the water is not pure, it can carry the sediments, other debris, waste material. So we need maintenance of irrigation canals for efficient operation of the water application. So we will study about maintenance of irrigation canals. We will study about the diversion headworks. We have canal headworks. It can be two types. We can have storage headworks in the form of dams where you store the water, and it can be diversion headworks in the form of weirs and barrages. So we will study selection of their site and layout for these weirs and barrages. What can be the various components and structures used in headworks and their functions. We have canal headworks. What are the different components, associated structures, and what are their functions? Measures adopted to control silt entry into canals. So because canals are constructed to divert water from rivers, rivers carry heavy sediments. We have to control the silt entry into these canals. As I said, that these can get deposited in the canals and can reduce the discharge carrying capacity. And also we would like to supply silt-free water to the crops. So for this, how to control, we use silt ejectors and silt excluders. So we will study in detail how they function and how they control the silt entry into canals. We will study about the irrigation works. So introduction to canals and regulators. How we regulate the flow of water into canals. We have canal head regulator. We can control the flow entry into canals through canal head regulators. These are off-taking canals, maybe from dams or rivers. We will study about the canal falls. For example, if we have this canal longitudinal section here, but the natural topography is such that the ground surface is here. So how we provide a transition here for the flow of water? So for this purpose, we can provide different structures that you might have studied in irrigation engineering also. If the change in elevation is small, we can provide what is known as a drop structures. If the change in elevation is more, we can provide structures known as chute. So these are basically known as canal falls. Flumes you might have studied in open channel hydraulics also. These are channels which carry water at or above the ground surface. We have canal outlets. How to measure the discharge, that the canals which carry the water to the agriculture fields, how you can distribute that water, how we can control and provide the required quantity, how we can measure the discharge, that how much quantity of water is coming to this field. So for that we provide structure that are known as canal outlets. We will study about the different types of canal outlets. And we have cross drainage works. As I already explained, that for example you have a stream flowing or a drain, and this is we are going to construct a canal. So how this canal will cross this natural drain or stream? So either there should be level mixing, that for example this canal water is allowed to mix, and then on the other side again it is withdrawn in the canal. This is called level mixing. Or we have to carry this canal above, which is known as aqueduct. Or we have to carry this canal below the drain, natural drain or any stream, that is known as siphon. So these are collectively known as cross drainage works. So these are actually small chapters: canal falls, canal outlets, cross drainage works. We will study their types and functions. And we will study about the monitoring of flows, telemetry system. So we need to know that how much quantity of water is flowing. For example, you have studied in hydrology the stream flow chapter. You want to monitor the flow at a particular point in a stream, that is the gauge station. So we want to measure the discharge, because that way we know that how much quantity of water is flowing in a stream or river. So that we can plan accordingly. And for this purpose you measure the discharge, and you already studied in your hydrology course how to measure the discharge. We have different methods. And once you measure the discharge, we can develop what is known as the rating curve, which is the depth versus the discharge relationship. And at any system, telemetry system, if we can measure the depth of water at that gauge station, then using the rating curve we can estimate the discharge, because measuring the discharge at different points all the time, it's very difficult. So that's why these rating curves, just you studied in hydrology, I give example here to let you understand. That is very important. So we can have automatic gauges that can record the depth of water, and then that is transmitted to the remote control rooms where the data is analyzed, stored. So we will study some introduction about monitoring of flows telemetry system. We will study about the water logging and salinity. So as I already explained, if the soil contains the salts that are not desirable for the growth of plants, so definitely the plant's growth will be adversely affected. Waterlogging is the raising of water table in an area up to the surface of the ground that will affect the productivity of the land. So that is known as waterlogging. So on one side, you see that when we supply the water to the crops, the same water can infiltrate through seepage, go down. So it can carry these salts which are present at the surface of the earth along. So on one side, it is beneficial. But on the other side, if the same water comes to the surface of the earth, then the same salts are brought again to the surface of the land, and it can affect the agriculture land productivity. So that's why this is very important, waterlogging. We will study what are the causes and effects of waterlogging and salinity, and then we will discuss with special reference to Pakistan, that what is the situation in Pakistan. So you already know that, for example, we have the Tarbela Dam. So the Tarbela Dam has a huge reservoir. There are different types of dams, but if we consider the earth and rockfill dam, then the largest dam in the world, earth and rockfill, that is Tarbela Dam. So because of the construction of the Tarbela Dam, because we store huge quantity of water in the Tarbela reservoir, what happened is that because of the seepage of the water, the adjoining areas, you see Mardan, Sawabi, so that areas, they were affected by this raising of the water table. And you might have heard that actually we run a schemes that is known as SCARP, Mardan SCARP, Sawabi SCARP. This is Salinity Control and Rehabilitation Project. So under these projects, what we did is that we provide drainage network so as to lower the water table and increase the productivity of the land in these areas. Salinity Control and Rehabilitation Project. So in the context of Pakistan, we will discuss that how these schemes were operated and managed for these areas to reclaim the land from waterlogging. So we will study the different methods that can be used for reclaiming the land, reclamation methods. And mainly we do it by draining the water from those areas. So that's why drainage network in irrigated areas, this is very important topic, and so important that drainage engineering is now a full course. We can study a full course on drainage engineering, how to drain the water. On one side we supply the water to the crops, but on the other side we must have a good drainage network to drain the excess water. So we will study drainage network in irrigated areas. And finally, we will study about the dams, different types of dams, what are the forces which are acting on the dams, based on which we can calculate stability of the dams, what is the criteria for site selection, and types of dams. We study about the reservoir sedimentation. As you already know that the water which is stored in a dam, it carries sediments. You might have studied Introduction to Sediment Transport in a hydraulics course. And then these sediments, they get deposited and can affect the storage capacity of the reservoirs. And delta formation, freeboard, which is actually related to the dams here. So we will study that how it is subjected to the wave run-up, because when the water flows in the form of waves, wave action, that is what is written here. We can calculate that. And on one side we construct the dams, because dams, they have many advantages. We store the water during high flows in the river and then use the same water during low flows in the river. So basically we are redistributing the water. Similarly, because of the dams, we are producing electricity, hydropower. From the dams, we are supplying water to communities, to industries, and to agriculture. Because of the dams, the water can seepage can occur, and they can recharge the groundwater reservoirs. So you can see that dams, they are very helpful in flood control. During flood, you have more water, and that we can store to protect the downstream communities from the damaging effects of the floods. So you can see so many advantages. But on the other side, there can be environmental impacts because of the construction of the dams. For example, construction of a dam, it changes the landscape of that area, the natural landscape of the area that is disturbed. Because of construction of the dam, we are regulating the river flows, so the natural ecosystems that are affected. Because of the dams, you see the water stays there in the lakes or these reservoirs, so you can see it can lead to spread of disease, because you already know that when water is standing, it can be home to different flies, etc., that can lead to disease also. This is also possible. Similarly, you see that I already explained that because of the dam, if the seepage is more, so it can lead to waterlogging of the nearby areas. So we will study some introduction to environmental impacts of dams. So this is the course syllabus. We are going to cover these topics in detail in the coming lectures. Now the course weekly schedule, this is the course weekly schedule, that in every week we should be able to cover these topics. So we have 7 working weeks, and then we will have the midterm exam. After midterm, we have 8 working weeks. So making a total of 15 working weeks, 7 before the midterm exam and 8 after the midterm exam. And then there will be final term exam. Assessment task activities. So the distribution of 100%, that includes 20% for the sessional marks, that is your home assignment and quizzes, making total 20%. So because this is a 3 credit hour course, we will have total 3 in-class tests. So if the classes continue online, we will have online quizzes, and there will be 3 take home assignments. The midterm exam, that is 1.5 hour written exam, and the weightage is 20%. The final term exam, that is 60%, and the duration is 3 hours written exam. So the final term, it will cover the whole course. So that is why the percentage, that is 60%. The recommended books for this course, we have irrigation engineering and hydraulic structures by Garg. So this is the book which is given in your curriculum, irrigation engineering and hydraulic structures. The second book which is given in your curriculum, that is hydraulic structures by Novak, Moffat. So this book is not available in the library, but this is available online and you can download from internet sources. Whereas this book, Irrigation Engineering and Hydraulic Structures, we have 54 copies in the Civil Engineering Department library. So if you are interested to get a hard copy of this book, 54 copies we have currently in our departmental library. So these are the 2 books which are given in your curriculum, but we have other good books also available to us. We have this Irrigation and Hydraulic Structures, Theory, Design and Practice by Dr. Iqbal Ali. This book is written by a Pakistani author and you can purchase also from the market. This is also a good book. Now the latest edition is Applied in Irrigation Engineering. So this is a book which is published from University of Agriculture, Faisalabad. This is published in 2017. So this is actually, the advantage is you will find the latest data and information related to irrigation engineering in Pakistan. So this book is not available in the library, but you can download from the internet sources. Whereas this book, Irrigation and Hydraulic Structures, Theory, Design and Practice, we have 21 copies available in our library. So you can issue this book from the departmental library. Next good book is Irrigation and Water Power Engineering by Pumia. And another book is Irrigation and Drainage Engineering. This is also a good book. It's published by Springer. You can download this from the internet sources. This book, Irrigation and Water Power Engineering, we have 86 copies in our library. 86 hard copies. Similarly, we have Irrigation and Drainage Engineering by Iqtidar H. Siddiqui, again a Pakistani author. So this book you can purchase from the market. Irrigation and Drainage Engineering. It is also a good book, very comprehensively. It explains about the different topics in irrigation engineering. And we have Irrigation Engineering by Sharma. This is also a good book. So mostly you can see here that the books here, they are written by Indian or Pakistani authors because they suit to the irrigation system that we have in Pakistan in the subcontinent. We have books on irrigation that are written by European authors or American authors, but in those books they talk more about the latest technology, the latest methods of irrigation, which are not yet widely applied in Pakistan. So we can read those books to get idea about the latest methods of irrigation. But the irrigation system that we have in Pakistan, so with reference to that, these books are more relevant and present relevant material. So that is why you can see that these books are actually given in your syllabus. For hydraulic structure, so this is a good book, but these hydraulic structures are also covered in these books. Clear? So if you want to, this is actually a specialized book on hydraulic structures. But all the hydraulic structures that we study in this course, they are also covered. So we stop it here, we take a break, and then we will continue after the break.